Hello everyone, welcome to lesson 411. Today we're going to talk about some more solution strategies. So we're going to kind of shift gears just to solving equations again, but we're going to talk about different ways that we can solve different types of equations. All right, we're going to develop what's called a graphical method for checking solutions. All right, so let's look at our first example here. In problem 4.1 here, we have a function y equals x plus 3 squared minus 5. And I have taken that function and I have graphed it over here so we can see the parabola that it forms. All right, and then instead of setting this thing equal to y, let's say we set it equal to 4. All right, so now it's like an equation, and our goal would be to figure out, okay, well, what is x? What value of x is going to produce a 4, right? Because the 4 kind of acts as an output, and we want to know the input or inputs, right? Because there could be more than one that produce a 4. All right, so we want to see those solutions, and we want to understand how can we see that on the graph. All right, so the strategy is like this. All right, we're going to take this side of the equation. So we're going to take the right-hand side of the equation. We're going to call it y1, and we are going to graph that, right, which I've already done. All right, so we take x plus 3 squared minus 5, and we graph it. And then we're going to take the left side of the equation, which is just a 4, and we're going to call that y2. And we're going to say y2 equals 4. And then we're going to graph this. So it's like we're going to get the right-hand side and the left-hand side, and we're going to graph those simultaneously. All right, so we've already got y1 graphed here. That is our parabola. And y2, when we graph that one, is going to be a horizontal line that goes straight across the graph just like this. Okay, it's just going to be this horizontal line right here. So this is y2, this is the left-hand side of the equation, and this is y1, the right-hand side of our equation. Okay, and where they are equal to each other, right? Because this is an equation. They want to know when these two things are equal to each other. When is y1 equal to y2? Well, on a graph, that occurs when they occupy the same point at the same time. So in other words, the intersection points, right? They are equal to each other here and here. Right, they're occupying the same point at the same time at these two locations. That means the input and the outputs are exactly the same at these 2 points. All right, so to find our solutions, right, when we solve an equation anytime, we always want to find the value of x. And since there's 2 intersection points, we're going to have 2 solutions for x. All right, so if I go to this one, this point has an x value of -6. Right, so that's going to be one of our solutions. And over here at this intersection point, this one's going to have an x value of 0. Right? So these become our 2 solutions. So just by graphing the left side and the right side separately and looking for the intersection points, just by looking at those intersection points, we can find our 2 solutions. You might think, well, that's pretty easy, and it's meant to be that easy. That's why graphs are so handy sometimes. But let's compare the graphing strategy to the algebraic strategy, right? And this is where we move things from side to side, or use factoring or quadratic formula to help us solve this thing. All right, so watch what happens when I try and solve this algebraically. My goal is to get x by itself. So what I'm going to do first is I'm going to add 5 to both sides. And this might be a little bit more familiar to you, like, oh yeah, this is what we used to do. Right, the 5's cancel. All that's left is x plus 3 squared. And then 4 plus 5 equals 9. All right, now our x is trapped inside of a parentheses with a square on it. So to get it out of that parentheses, we have to undo a square. And the opposite of squaring is square rooting. Okay, so I'm going to square root this to get rid of the square. And whatever I do on one side, I have to do on the other side. So that way the square root and the square cancel each other out, and we get x plus 3. Okay. Now over here we take the square root of 9, and we have to be careful because when we square root a number, we actually get 2 solutions. We're going to get a positive 3 and a negative 3. Right? So we say x plus 3 equals either positive 3 or negative 3, and I can actually set that up as 2 different solutions over here. So I can say x plus 3 equals positive 3, and x plus 3 equals negative 3. and then I would have to solve both of those equations. All right, so for this one, we would subtract 3 from both sides. 3's cancel, and we get x equals 0, which is one of the solutions that we got graphically right here. Now let's see what happens here if I subtract 3 from both sides. All right, the 3's cancel, and we get x equals, well, negative 3 minus 3 is negative 6. Okay, so there it is algebraically, which was a bit more work than what we did graphically, right? So we have our graphical solutions, which matched up with our algebraic solutions, but I do feel like in this instance, the graphing method was a bit quicker than the algebraic method, okay? So let's take a look at another example. We'll actually get the calculator out for this one so you can see how to do that on your calculator. You'll notice that it says solve algebraically, solve graphically. All right, so when we get to a quiz or a test, if it says solve algebraically, you're going to be expected to show your steps and everything that you did, like moving things from side to side, or if you use quadratic formula or factoring or whatever it is you did. And if you solve graphically, you're going to use a graph. All right, so you have to use that specific method. All right, so let's solve this one algebraically first. To solve this one algebraically, first thing I want to do is I want to make sure that it's set equal to 0. So right now it is set equal to 6. So I'm going to move that 6 over to the other side. I'm just going to subtract 6 from both sides of the equation. Okay, so we get 6 minus 6, which is 0. And then over here we'll get x squared minus x minus 12. And we've seen this before, so at this point you have options. You can either choose to factor or you can use quadratic formula. Okay, so I'm going to set up my box in Diamond because I like factoring. It's a lot quicker than quadratic formula. So I'm going to draw my box with 4 compartments here. Here's my Diamond. And I'm going to set this up so I've got x squared going in the upper left-hand corner. I've got a minus 12 going in the bottom right-hand corner. And then I'm going to throw my negative x in the bottom of the Diamond. I'm going to multiply to get negative 12x squared. And then I'm looking for 2 numbers, and I'll put my 1 here. I'm looking for 2 numbers that multiply to negative 12, but add to give me negative 1. So that's going to be negative 4x and positive 3x. So negative 4x, 3x. Okay. And then I get my outside numbers, right? X times x is x squared. X times 3 is 3x, and x times negative 4 is negative 4x. So my factors are x minus 4 and x plus 3 equals 0. And then if I solve this, right, we set each of these equal to 0, we get x equals 4 and x equals negative 3. So there's my 2 solutions. All right, now let's just do it graphically. Let's see what happens when we use the graph to help us out with this. So I'm going to pull up my calculator here. So remember, to solve this thing graphically, what we want to do is we want to take the left-hand side of the equation and the right-hand side of the equation and define those to be 2 separate functions. So I'm going to say that y1 equals x squared minus x minus 6, and I'm going to say y2 is equal to 6. I'm going to graph both of these. So let me grab my calculator and we'll do that. And let's do a detached LCD here. So you got a nice big view going on. Okay, so here we go. And I'll clear these out. So first hit y equals. We're going to go up to y1, and I'm going to put in my function here. All right, so we've got x squared minus x minus 6. And then remember in y2 we're doing 6, so just a 6 there. And let's hit graph. Okay, so the first function we should see, that is our parabola. All right, so that's y1. And then the second function that we see, that is the horizontal line that comes through the graph at 6. Okay, and so when we look at this, we're looking at the intersection points that occur here and here. And so when I look at this first intersection point, that occurs at an x value of 1, 2, 3, so negative 3. So we say x equals negative 3 is one of our solutions. And then I'm going to go back to my calculator, and I'm going to look at this other intersection point over here. So if I come straight down, right, that's going to hit right here for an x value. So that's going to be 1, 2, 3, 4. So that'll be a positive 4. All right, so there's my solutions that I got from the graph. And you can see we got the same exact thing, right? It just seemed like the algebraic method was a little bit more work than the graphical method. Now the algebraic method has its solutions. It is a little bit slower, but it is much better at finding exact solutions than graphical, because sometimes looking at a graph it can be hard to line up those values right on the tick marks and things like that. So algebraic does have its advantages. Graphical can be quicker, all right? But it's another tool to put on your tool belt when you're solving equations. All right, let's try another one. All right, so this one's a little bit different. It's got a square root going on. So first we're going to solve it algebraically, and then we'll look at it on the graph and see what we get. All right, so let's do this thing. I'm going to draw my line better than that. Oh my gosh. Here we go, it's better. All right, and I'm going to start moving things around. My goal is to get x by itself so that I can solve this thing. So I'm going to start with the plus 9 on the end. I'm going to subtract 9 off the end of this thing. The 9's cancel. We get 3 square root 4x minus 8. And then when I do 15 minus 9, we're going to get 6. Okay, remember the 9's canceled there, that's why I did that. Now we have this 3 over here in front, so it's 3 times this square root thing. So I'm going to undo the multiplication of 3. I'm just going to divide this side by 3, and whatever I do on one side I have to do on the other. So over here the 3's just cancel each other out, and we get the square root of 4x minus 8. And then over here we get 6 divided by 3, which is 2. All right. So now my x that I'm trying to get by itself is trapped inside of this square root. And so I need to get rid of the square root. The way I'm going to do that is I'm going to square this side of the equation, right? Because the square root and the square, they cancel each other out. But whatever I do on one side, I have to do on the other side. Okay, so if I square over here, I have to square over here. Okay, so let's do it. The square root and the square cancel. We get 4x minus 8 equals, and then 2 squared is 4. Okay, so keep going here. So I'm going to add 8. All right, 8's cancel. We get 4x equals 12. And then we're going to finish this off by dividing by 4. 4's cancel. I'll write my solution over here. We say x equals, well, 12 divided by 4 is 3. So there's our solution. All right, let's do that same thing on the graph. You'll see how much quicker it is using the graph. So I'm going to pull up my big screen here. So remember, the way that we do this, we take the left-hand side of the equation. I'm going to call that y1, and the right-hand side of the equation here, I'll call that y2, right? So we're going to say y1 equals 3 square root 4x minus 8 with a plus 9 on the outside. Then we're going to say y2 equals 15, right? So this 15 all by itself over here becomes its own function, and we're going to graph it. Move this so we can see our two functions here. I'm going to go to y equals. I'm going to clear these out. And then I'm going to go up to y1. I'm going to say 3 square root 4x minus 8. And then I'm going to get out of the square root by hitting the right key. And then hit plus 9. Right? That way that plus 9 goes outside. Then I'm going to go down to y2, and I'm going to put that 15 in there. Right? So there's my left side, there's my right side. Two separate functions split up between y1 and y2. All right, and then I'm going to hit graph. See. Okay, so we're not seeing anything, and that's not a bad thing. This means we might need to zoom out a little bit, right? Because our graph might be off of what our viewable window is there. So I'm just going to zoom out, see if I can see it after I zoom out. There it is. And there it is. Okay. So I'm looking at this graph. I see an intersection point. It's happening right here, but it's kind of hard to tell which tick mark it lines up on. I think it might be better to go to the table and figure out where it's happening at. Okay. So let me show you what to look for on the table. All right. If it's not easy to see on the graph, sometimes it's easy to see in the table. So I'm going to hit second graph. I'm going to go to my table. Okay, and what I'm looking for is for y1 and y2 to be the same thing, right? If they're going to be equal, if I want y1 and y2 to be the same, then they have to have the same output. So I'm going down here and I'm looking. So this is error and 15, that's not the same. 9 and 15, that's not the same. 15 and 15, that's the same. And look at the x value where that happens, right? So this is our x value. It happens at 3. So that's telling me that my solution is x equals 3. Okay. And notice we got the same thing graphically that we did algebraically. All right, let's do one more. This one we're only going to do with a graph, all right, just to make sure we got that graphing method down. All right, so let me pull up my thing here. We got our screen. I'm going to go back here. Now remember, the way that we do this, we take the left-hand side here. I'm going to make that y1. We take the right-hand side, and we're going to make that y2. So when I go to my calculator in y1, I'm going to put 4 absolute value, 8x minus 2, and then for y2, I'm going to say it's just 8. Right, so there's my left-hand side, there's my right-hand side. Now watch me closely here because putting in an absolute value can be a little bit tricky. Okay, so clear out our old stuff here. I'm going to go to y1. We're going to say 4. Now to get an absolute value bar, what you got to do, you got to hit second 0. It'll bring up this catalog, and the very first option is this ABS thing here. So when I hit enter, it'll enter in an absolute value bar. All right, so I'm going to put in my 8x minus 2. So there's my left-hand side. Now here in y2, I'm just going to put an 8, hit enter, and then I'm going to go and graph. Remember, I'm still zoomed out a little bit, so I can zoom back in if I need to. Let's see what we're dealing with here. I'm going to zoom back in because I can't see that very well. Okay, so there's this is my absolute value function right here, and then I can kind of see here's my horizontal line. So it looks like we definitely have a solution at 0. So I'm going to mark that one down. That one I can see. So x equals 0. And then I'm going to go back to this thing, and it looks like the other one might be at 1, but I'm going to double check it. I don't know if it's before 1. It looks like it might be before 1, so I'm going to check it in the table here. And so, yeah, so I see we would need them both to be 8. I'm not seeing 8 pop up there. So that's one of the disadvantages to doing it graphically, right? So when I go back to my graph, let's zoom in here and see if we can get real close on that solution. So what you do is you just move your mouse up here. You can see your little cursor right here. Move that up towards that area where the solutions are. And it takes a little while on my end here. There we go. I'm going to move over here, and I'm going to zoom in. So it looks like it's at about 0.53, but I'm going to zoom in just to get a little bit closer, and that's why it's not popping up on the table, because it's not a nice integer solution there. So I'm just going to zoom in, get a closer look, see what's happening. Here we go. So we can see this one, and this one's right here. Let's go. Yep, right on it. So I'm going to say that second solution is approximately 0.5. All right. So this one is more of an approximation. This one we were able to tell happened right on 0, but this one's an approximation, and this is kind of the weak part of just trying to look at solutions on a graph, is that it's hard to tell exactly what it is. If we solve this algebraically, we'd be able to see that exact solution. All right, guys, that's it for today. I gave you a few problems in the practice problems to try so you can practice your graphing method. Let me know if you have questions in the Zoom chat. Have a great day.